Hey everyone, in this video we want to look at a pretty cool example of what we've learned so far, and that is we want to destroy a space station. Now I was looking for an example that, looks pretty cool, but can work without constraints. And this is when I came up with the idea of doing something in space, because space is actually pretty great because we find it interesting because I guess it's not very similar to what we're used to, but at the same time it's actually pretty simple to set up because there is no gravity. We don't need constraints to keep the things together because by default there's nothing that would pull them apart anyway. And we can also use a relatively simple lighting and shading setup because basically all you have is a single light source, and that would look like this, for example. It just comes from one side, and if we turn off the grid and turn the background dark, we're already basically in space and it already looks interesting. Now the space station I have linked on the site. You can download this from the internet, and the cool thing about this space station is that it already comes with a lot of small pieces, so this is perfect. But I had to adjust a couple of things because I think it comes from Max or something. So first of all, the scale was off. It needs to be big, but it was way too big. So here, this is Tommy, and this is our space station now. So it's pretty big still. And because of the different orientations of the programs, I have to rotate this thing around. I mean, of course, there is no orientation really in space, but what I want to do is I want to rotate it by 90 degrees in X so that we can look at it from roughly this angle. And again, with the lighting, it would look like this. So pretty cool. So let's actually not think too much about the object first, even though we will take care of it. But if we use an exploded view, we can see that this is made of a lot of different pieces. And this is why this is such a nice example. We already have so many small stuff that will be part of our destruction. But also, and this is something we will talk about in a second, we have some big pieces that we have to take care of. So for now, let's start with what we have, and then we can see the problem. And what we want to do is we want to crush this thing with a couple of meteoroids. So I have one prepared here. There it is. There you go. And let's make the lights invisible. A simple rock, with one mountain and then another mountain on top to add even more detail. And then I reduce the whole thing to save a little bit of geometry. And then we want, of course, to put this into RBD bullet solver. Now, of course, the space station itself is active. So this is something we can turn with an assemble into packed pieces. And let's call this space piece or station piece maybe in the prefix and pack this. And we do the same with our rock here, or our meteoroid. So let's call this meteoroid. So this is that. And the reason why I do this with an assemble is that I will probably end up with more than one. So let's start simple and see what happens. So in the RBD bullet solver, we merge both in. We don't have any collision object here. And if we would start this now and press start, we would see that the space station, even though it's very slow, it will fall down. That's not what we want. There's no gravity in space. So let's turn this off. Under forces, we can just turn off gravity. But what we also want is we want our rock here to fly into our space station. So first of all, let's make sure that we have a scale that makes sense. And of course, this is purely up to your taste, but let's make this maybe this size. Yeah, that's not too bad. And then let's crush it from here onto here. So the first question is, how do we get this to move there? Of course, what we can do, we could hand animate that. That's not a bad idea because then you would have less problems with collisions that react out of it. But I think in this case, what I want is I want the rock or the meteoroid to react to the space station. So I will keep both objects active and not hand animate the rock. That means we need to give the rock or the meteoroid a velocity. So let's do that. And the question here is, what is the velocity we need? Let's double check. Yes, it's already packed. And we can, of course, just, guess the velocity direction. But why don't we just put the position of the impact in the center? And the center of the world is here. So let's move this with a transform, the space station, a bit further forward. There you go. And then we can position our rocks or one meteoroid here. And the idea now is instead of trying to figure out the exact right vector towards the space station, we just use our little trick of using the position for our velocity. So if we turn our position to the velocity and we look at the direction with the velocity visualization, which it's not easy to see, so let's quickly kill the geometry. There we go, there it is. And as usual, it's in the wrong direction because it should be negative, and I always forget that. And now when we normalize this, it will have a speed, so to say, or length of exactly 1, which means we can now multiply this with the speed we want. For example, by creating our own parameter here. So let's set this to 10 and let's see what happens. And our packed geometry now has a velocity towards the center of the world. And you can see our meteor is actually moving. It's a bit slow, so let's increase the speed here. And while we're at it, let's create a camera so that we have a good angle that we can see the result from, maybe something like this. And what I would recommend when you want to show something big, use a wide lens, because then things tend to look a little bit bigger. So maybe 30 millimeters and or maybe even 25. I just noticed that works well for space and everything, because then the whole thing, the whole space station feels even a bit bigger. When I turn on the light, and let's call this space cam. Actually, let's for now not look at it with the light, and let's run this and see what happens. And we basically got what we wanted. So there's our meteoroid, a bit boring, and then it crashes in and we see a couple of problems. First of all, the meteoroid will be, moved away from it quite a lot, but we can also already see why this whole thing is so cool, because as soon as we have an impact, because nothing is connected with each other, stuff starts to fly away and we get all kinds of detail, of course, based on the amount of pieces we have. And this is why I like this example so much. It gives you so much for so little effort. Okay, but nonetheless, what I don't like about it, and let's look at it from a different angle, is that actually the angle is pretty good, that it breaks off here this wing, but then the meteoroid is moved by the station too much. And the reason is, of course, the mass. Because the mass is currently calculated based on the volume by default, based on the density. And it's again up to you how you want to deal with this. Either you change the density or you change the mass as an absolute number. Personally, as you know, I prefer to set the mass directly, because this way I have the feeling I have more control. So we can create a point wrangle for each part and just set the mass directly on it. For example, for the meteoroid, I set the mass to, which is a float, to let's say 100. And for the space station, I set the mass to 1. So again, it doesn't really matter the actual number, really. It's more about the relationship between the two objects, or the many objects. And what's important, if I would run this now, it wouldn't work, it wouldn't change anything, because the mass will be ignored, density would be considered. But when I use mass, I have to directly put this in here in the override attributes from SOP, so that it will actually read it out. So let's give it another try with the changed mass of 101. And this now looks like this. There comes our slowly moving meteoroid, and you can see it really pushed the stuff away. Now we actually see the problem that I mentioned in the beginning, and that is, now that we hit our big pieces here, it might look a little bit boring. I mean, maybe that's exactly what you want. And again, I love all the small details that are flying away. But what we can do now, which I wanted to do anyway, is let's actually create more than one meteoroid. So we have everything now. And the cool thing is, since the velocity is always pointing towards the center of the world, we can just move the second meteoroid around, maybe to something like this, and it will still hit the same point when we don't have to change anything. Let's quickly have a look what happens with two meteoroids. And then we will have a look at how to break up the big pieces of the space station so that they can break as well. But first I want to see how this looks like now. So it looks like this now. Again, we have to deal with the rotation in a second, but that looks nice. Oh, what was that? What's happening here? Wait a minute. Look at this one here. It moves around in a really strange way. So if you have something like that, when an object moves around in a way that makes no sense from the simulation, then this could be an indicator that there's something wrong with the name attribute, because this thing is now driven by some kind of a transformation. And when we look closely, it actually moves around. Can you see that? The second meteoroid. What happened here is I just copied my first meteoroid one by one without thinking much about it. And the mistake I made here is that the assembles here both use the same prefix. And that means when you look at the name attribute here on the points, both are called meteoroid 0. And that means they basically behaved like one meteoroid. And this is what just happened. So let's make sure we change the name. There are multiple ways of doing this. We could just, change the prefix differently for each, but then the numbers are a little bit weird. Or we use a name node to override it. Just be careful, this is packed already. So you have to set the name attribute to point, otherwise it doesn't work. And then we call this meteoroid 1, and this seemed to work. And the other one, meteoroid 2. There you go. And now they both have different names. And let's see how this looks like now from our camera. There they are. And that's pretty nice, actually. They don't seem to behave in a weird way anymore, and our space station gets properly destroyed. But we can also see the problem again, that the big pieces stay in one piece. So let's fix this first. So let's finally take care of that. And the way I want to do this is up here, the geometry. I want to have all the big pieces broken up with a Voronoi or an RBD material fracture, for example. But the small pieces I want to leave as is. So how can I do this? Sure, I could, manually select each piece with, a 3D connected geometry or something, but this, that's not a very procedural way of doing it. What if later on the geometry of the space station is changing because the modeling department made it change? What would be better here is to use a measure tool, for example, to just find the big pieces as we've seen in the measure video. So what we can use here is either the parameter or the area or the volume. In this case, I think I will go with the volume, but it depends a little bit on your case. You have to play around with what works for you. And as we've seen in the measure video, you have to be careful. Currently, the volume will be different for each phase, because basically each primitive, each phase in this case, will be calculating its volume separately, which for some reason even gives you results. But we have to be careful. We don't want the volume of a single phase. We want the volume of the object it belongs to. So let's make sure we set this to per piece. And how does the phase know what piece it belongs to? Via a class attribute. And we know the class attribute comes from a connectivity node. And you have to be careful here because when you look at the numbers, nothing has changed. And that's because this is the volume is an attribute on the primitives. But by default, the connectivity creates a class attribute on the points. So let's make sure we switch this to primitive, and we should see the result by seeing that the volume has changed. A lot of phases now share the same volume, and the volume is much higher than before. So that's a pretty good indicator. As you just saw, there were some negative numbers as well. I'm not sure about this. So maybe volume in your case will not work well, but let's see what happens first, right? What I want to use is a split because I want to separate the big ones, the big pieces from the small pieces. And like we said, we measured the primitives, and to be more precise, the volume of those primitives. So let's separate everything where the volume is higher than, I don't know, 500 maybe. And there you go, this actually worked. There are a couple of outliers like those here, which I can't fully explain. I think that's because they're flat and they create some kind of wrong result. Or maybe actually thinking about it, they might be part of the same object. All kinds of weird things can happen. But overall, it's a pretty good approach. So maybe higher than 100, then we get those thingies here as well. So this doesn't seem too bad. As an alternative, we could have used the parameter, for example. So let's see how this would look like. There you go. And of course the numbers are probably different. So this doesn't work that well in my opinion. So you have to, check on your case what works for you. In my case, I think volume is pretty good. And the cool thing is on the left side now, the big pieces come out. On the right side, all the other pieces come out. And maybe we could go a little bit more aggressive here. Yeah, I think that's fine. Are those separated? Let's use an exploded view. Yeah, okay, so some pieces like here in the front, they seemed like being one object, but there are multiple ones. So I think this is fine. So let's keep it at that. And those are our big pieces. And we could break them up, like I said, with an RBD material fracture or a Voronoi fracture. I go with a Voronoi fracture because it's quicker. So let's just scatter on the surface for now. This is fine. Let's work by using the density. So it's based on the size. And we have to go pretty low because it's such a big space station. So maybe something like that. And we do not want it to be too even. So maybe something like this. Okay, here are a lot of points. I think there's small objects here. Yeah, so maybe like this. So we use a Voronoi fracture to break those pieces up. There you go. And with an exploded view, we can see our result. Yeah, I think that's fine. It's actually even too fine. So let's maybe even go lower with the density. Yeah, that's enough. So this is the idea. The big pieces will be broken up. The rest is fine. And this is what we can do with a simple measure and then a split. So let's merge those pieces back together now because they're still part of the same space station. There you go. And this should now be assembled. There you go. And we have 7,550 pieces roughly. So let's see how this looks like. And actually, before we press start again, let's add another thing because it's always looking so boring that those meteoroids here move in a straight direction without rotating. Let's add a little bit of rotation because we know how to do this as well. So we cannot just set V for translate velocity, but we can also set W for an angular velocity. And I don't care about a particular direction, so I think I will just use a curl noise here. And this, of course, is just a start velocity. We might have to increase that. So let's copy this for the other one and let's see how this looks like through our camera. So this is what we got right now. And you can see now that the ring here breaks up and also the front breaks up. You could do this even nicer. I would probably reposition a couple of things like the meteoroids and all that. But I think it's showing the idea and it's relatively straightforward and looks pretty cool. I think the rotation of our meteoroids is a bit too subtle. They are rotating, but as expected, it's not strong enough. So let's fix that by adding here a speed controller as well. And let's maybe use 10 here. And let's do the same on the second one. And then we should see a little bit more rotational movement. And here we go. And I think it looks a good bit more interesting when they rotate a little bit. So that's great. Another thing, maybe we could adjust the mass again, because I think they are, still bouncing off a bit too much. I would like them to, feel even stronger than that. So maybe double the mass for each. And by the way, this time I will turn on the light. Let's see if it's not too dark. Okay, unfortunately it is a bit too dark, but later on we will have indirect lighting, which is missing here. But I think this will look pretty nice. So let's move on here. I think we can stop here. Even we can adjust parameters all the time, but I want to talk about one last thing, and that is maybe you will see some weird behavior when you try that. And we were lucky a little bit that this didn't materialize too much. But actually our geometry isn't that great. We got away with this, but when we only simulate the space station and press start, then sometimes you can see something like this. Actually, we didn't even have to be that close with the camera. Sometimes this happens. The whole thing starts to break out of nowhere. This time we didn't have that, but I've seen this a couple of times with this example. And what's going on here is that you should absolutely now check what your pieces actually look like. In our process, something might have gone wrong, and we can show this with, of course, show geometry representation, which can take a while to calculate. And then you will see sometimes you have pieces like those. So those massive pieces that are kind of, covering everything, because of course we know that objects will be turned into convex pieces at simulation time. So let's try to figure out where this comes from. A good trick here is to use the convex decomposition, because it basically does the same as it does internally. And then we can find those pieces and deal with them. And here you can see here in the ring, this still happens. So first of all, let's check if that happens on the big pieces. And as we can see, they look actually pretty fine. You could, I think, use the visualization to see how this looks like. This is actually pretty fine because it comes from a Voronoi fracture, which is usually clean. So let's look at the smaller pieces. And here we can see we have some pieces that behave a bit strange. So let's figure out which ones those are. And actually, when you just turn it off, you can see it. It's those rings here. So always double check that your geometry is clean. So it's those rings here that create a problem, because we didn't catch them, because technically they don't cover a lot of volume, but they are one big, really concave object. So honestly, what I would do here is either you break them up again with a Voronoi fracture, or you just delete them. Why not? So let's put a blast in here for now, because that's the quickest solution. And as you can see, the rest seems to be okay. So with that change, let's simulate our space station again. Again, I disconnected my meteoroids for now to just see if the space station by itself is stable. And here now my representation was still on. You can see it looks much cleaner now. So let's hope for the best. So as you can see, it doesn't explode anymore. And from far away, it looks fine. But actually, when you look close here, there's still a problem. Something is, pushing those pieces away. We could now investigate what's going on with those, probably a similar problem. And I think what I would probably do is I would split them off separately and then maybe Voronoi fracture them again or something like that. I don't want to spend too much time on this. You get the idea. Always check the representation of the concave version of your geometry. But we bring back our meteoroids because this little thing we will not see. And to finish this, let's talk about the rendering. We already said, the shading obviously is something, materials that you would use in space. I don't do this here for this example because it's too much work. But, some gold, some aluminium, and all this kind of stuff. That's pretty straightforward. And as a light, you really just use a directional light or a sunlight that really just comes from one direction. And it's usually pretty harsh because there is no clouds or something that softens the sunlight up. And what I wouldn't do is any kind of filler. Even though that seems, natural, it's actually completely dark. But to be sure that it's not too dark on the dark side of the space station, if you look at the render here, just make sure that you turn on the indirect illumination, because then you have the bounce lights from the very bright sun. And that's something I forgot. The sun is usually then very bright. And this indirect illumination will brighten up certain areas, and then you will see much more of your effect. So the rendering I'm showing here, I think, is not exactly what we built here because I prepared another example, but it's the same concept, just with a little bit different numbers. Okay, so create your own space station destruction, and it wasn't actually that complicated. We had created some meteoroids, and what we basically said there was velocity, W for the rotation, both just start values. And since there is no drag or anything, they will, stay intact. Then we changed the mass to control the impact. And for the space station, just make sure that you separate the small pieces from the big pieces so that you can break up the big pieces with a Voronoi fracture, for example, so that you have overall, small pieces that can fly away. And always be careful with your concave version of those pieces. So there will probably some pieces that will create some problems that you have to solve. But once you bring everything together, it can look like this render here, which is pretty cool, right? And the effort is not as big as it seems. So I hope this is helpful. Thanks very much and see you later. Cheers.